Great, so let's start writing our move class. This is going to be our first class for the Tic-Tac-Toe project, and we are going to represent a move in the game. How are we going to do that? Let's start by defining our move class. With the class header, right here we have the class keyword, the name of the class, and the colon, just like you learned. Each move is going to have a particular value. Why? Each particular cell in the board has a number that identifies it from 1 to 9. So that is what we're going to call the value of the move. So to create a move, we are going to specify the value, and for that we need to define the init method. We add value as a parameter, so we can pass it as an argument when we create an instance of move. Great, so now we have to create the instance attribute, value. Right here we are using the parameter, and let's make this attribute non-public. We're going to make it non-public right here, but we are going to create a property for this attribute. Why? Because we want to make it read-only. We don't want to modify the value after the move has been created. Awesome, so now we can create move objects with a particular value. But a very helpful method that we should also implement is a method that will return true if the move is valid and false if the move is not valid. This will be very helpful when we take user input to check if the value that was entered by the user is within the valid range of values that we can accept. So right here, what are we going to do? We are going to return either true or false. But what are we going to check? We're going to check if the value is less than or equal to 9 and greater than or equal to 1. This is the condition that we are going to check. If this is true, then the value true will be returned. And if this is false, false will be returned. Great, we have our method right here implemented. And now we are going to implement two methods that will be extremely helpful for this project. There are several ways of implementing this particular functionality. We will see, I will mention some of these alternatives, but we will implement them in this case as methods. Remember that in our board we have 9 possible options, from 1 to 9. The user is going to enter a value from 1 to 9, but that value doesn't really tell us anything about the row and the column where the move is located. The row and the column that the user chose for the move. So we're going to have to calculate that somehow, and that is exactly what we are going to do in these methods. Get row and get column. Let's define them right here, and then we are going to implement them. Get row and get column. We can use the pass statement to just fill the body of an empty method until we implement it, like we did right here. So let's start implementing get row. We want to get the corresponding row of the move based on its value. So if we take a closer look at the board, we can see that the values 1, 2, and 3 all belong to row number 0. If we think of it like a list in Python that starts counting from 0 for the first item. If the value is either 1, 2, or 3, we could check this using the in operator and checking if the value is in this tuple that contains the values 1, 2, and 3. If that is true, if it's either one of those values, then we will return 0, because this represents the first row on the board, or the top row. Then, if we go to the second row, we will see that the values 4, 5, and 6 belong to the second row. So, we check if the value is either 4, 5, or 6, then we return 1. This is the second row. If the value is in this sequence, so if it's either 4, 5, or 6, then this condition will be true and we will return this value. Great, so that is for the second row, and we have a third row, but for that we just need to return 2 because it is the only option left. If it's not 1, 2, or 3, it's not 4, 5, or 6, then it has to be either 7, 8, or 9. So that means that the move refers to the third row. Awesome! So now we have the basic structure of how we're going to get the row that corresponds to the move object that we are creating. We get the row, but we also need the column. So let's implement this method that we have right here. This time, the logic is exactly the same, but we are going to take the values per column. If you see right here the structure of the board, you can see that the numbers that belong to the first column are 1, 4, and 7. So let's say, if the value is in 1, 4, or 7, if it's in this tuple, if it's either one of these values, then we return 0, because this would be the first column. We should do the same for the second column. Now the values will be 2, 5, and 8. You can check the structure of the board again to confirm that these values are indeed present on the second column of the board. And by default, if these conditions are false, then that means that the value belongs to the third column. So we return the number 2. Remember that we are starting to count from 0 instead of 1, because this is going to be very helpful when we represent the board as a nested list. We're going to have an outer list, and each row is going to be a list. So we can use these indices to access the different rows and columns of the list. You will see how this works when we start implementing the board class. But trust me, this will be very helpful. PyCharm is letting us know that Pep8, the Python style guide, recommends adding 2 spaces before an inline comment. So this is a really nice tip that will help you keep your code clean and more readable. So now we have our move class implemented. Let's go over the code of this class quickly before we move on to our player class. We have the class header right here with the class keyword, the name of the class, move, and a colon. The colon is very important. We have a blank line, and after that we have the init method. We take value as an argument when we create an instance, and we assign that to an instance attribute that is non-public. We create a property for that attribute because we want it to be a read-only property. We can only access the value of the move, but we cannot change it because we are not creating a setter for this property. So we are sort of like protecting the value. Then we find the isValid method. This method is going to return true if the value of the move is valid, or if it's between 1 and 9 inclusive, if it's one of the cells on the board. And right here we have the 2 methods that are going to get us the row and the column of the move. Each time we call these methods, we're going to get the value that corresponds to the row and the column of the cell that the user selected for that move. Awesome! This is our move class. So take a look at this code carefully, go over it if you need to one more time. When you're ready, move on to the next video, and I will see you there. Great, now we have our move class. So before we start writing our player class, let's test how the move class works and that it works correctly. So let's start by creating a move instance. Right here, below the class definition, right here we are not indenting the code. This is right here at the same level as the class keyword because it is not part of the class. It's part of the main program, and we are creating a move instance. And right here we see a warning that is telling us that we need to pass something as an argument. Remember that. Let me draw a diagram right here real quick. This is our board, and these numbers represent the positions on the board. The user will enter a particular value that corresponds to this position from 1 to 9. We need to pass one of those values to create a move. So let's say that we pass a value from the first row. We need to test all the rows and all the columns, so let's test this with the number 1. We're going to create a move for position 1. Great, so after we have the move, we can check if the move has a particular value attribute, or in this case, a property. Okay, so we can print it. And if we run the code right here, we see the value 1, which is the value that we assigned for this move. Great, now let's test if the isValid method works as we expected. it should return true if the value is between 1 and 9 inclusive. We have 5 different possibilities that we should test. We should test a number that is less than 1. We should test a number that is greater than 9. We should also test these boundaries of the interval, the bounds of the interval 1 and 9, and we can choose a value in that range. And that will basically test the method appropriately. So let's do that. Let me zoom in so you can see this better. We have the move, and then we are going to call the method isValid. Okay? This method doesn't take any arguments, it just takes self, so we just need to call it with empty parentheses. And we know that the value of the move is 1, so it should be valid, the value should be true. Right here we see true, which is what we expected. Now if we pass the value to, for example, a value in the valid range, we also see true. Let's test another value in that range. This is true. Now if we test 9, which is a boundary case, for the interval we also see true. That is what we expected. Now let's test this with a number that is less than 1. For example, 0. That is no longer a valid value, so we should get false right here. And this is false like we expected. And we should also test this with a number that is greater than 9. For example, 10. And we see false. The move is no longer valid, so the method is working like we expected. Awesome. We tested this method, so now let's test getRow and getColumn. For getRow, we need to check if the correct value is returned for a number on the first row, on the second row, and on the third row. So let's do that. Let's change this to an actual valid value. And right here, we are going to get the row. Okay? Of this move. We know that the value is 2. So this value corresponds to this position right here. It is on the first row. Right here, let me add this. Row 1, row 2, and row 3. Okay? And right here, we can add this to the diagram. Column 1, column 2, and column 3. Right here. So we can have like a visual guide or representation of the board. Let's run the code. This is row 1, row 2, and row 3. But what is happening? Why are we getting the value 0? We set it up like this to return 0 for the first row, then return 1, and then return 2, because we are going to work with lists. And lists actually have indices. We're going to work with these indices in our code. So this is actually row 0. Then we go to row 1 and finally row 2. The same with columns. 0, 1, and 2. So intuitively we might think of them as the first row, second row, third row. But when we represent their indices, we will start to count from 0. Now that this is clear, let's test a position at a different row. At row 1, the second row. Let's say the number 6, which is this position right here. Let me run the code, and we see the value 1 now, which is correct. Row 1, if we start to count from 0. And let's also test a different row, the third row, and we see the value 2, which is correct. So this method is working like we expected. Awesome. Now let's test getColumn. We should also test a number in each one of these columns, and we should get the numbers. For example, 4. Let's test number 4. This is on the row 1, but it is on column 0, on the first column, right here, this position. So we should get the number 0, because right here we are getting the column of the position, which is 0 in this case, and that is correct, right here. Column 0. Then let's see what happens if we try to get the column of the value 8. Right here, if we run the code, we see the value 1. And that is correct, column 1. And finally, let's check what happens with the value 3, which is 2 in this case, and that is correct. It is right here at column 2 if we start to count from 0. Awesome! We tested all the methods in the move class, and this is basically how you can test your classes quickly in your program. You can use different test cases. For example, when you have a range of values, you can test values that are not in the range, values that are in the range, and the boundaries of that range or of that interval. Those are typically the test cases that we use. And if you have a conditional, you should test all the branches at least once, okay? Awesome! So now let's move on to the player class. When you're ready, go to the next video. Welcome back. Now we're going to start writing our player class. We have the move class, and now we have to create a new file for the player class. We're going to keep our classes on separate files. So right here, you can see that I have a main file where I wrote the move class. What I'm going to do is I'm going to refactor that file, and I'm going to rename the file to move. And I say refactor, and you can see that the file was refactored correctly. Now we have a move file. So we're going to create a new Python file. And we're going to assign the name player. So we have a new blank file. Great, so let's start writing our player class. First of all, we write the class header, the class keyword, and the name of the class. In the game, we are going to have two types of players. A human player, which is going to be interacting with the game through user input, and a computer player that is going to select a random position in the board to make the move. So we have to define or create a way in our class to identify if the player is the human player or the computer player. So how are we going to do that? We are going to do that in init. When we create the instance, we're going to specify if the player is human or not. By default, the player will be a human player. That is why right here, I am assigning a default value for this parameter. So we are going to assign this to the instance attribute is human, right here. Each player will have an associated marker, a particular symbol that we're going to use during the game, like X and O, which is a traditional pair of symbols that we use for tic-tac-toe. How can we know which marker to assign? Well, we check if the player is the human player or not. And what do we say? We say, if the player is the human player, we are going to assign a particular value as the marker. We're going to assign the string X. So when the human player makes a move, we're going to have an X on the board. But if the player that we are creating is not the human player, if it is the computer player, then we are going to assign O as the marker. This is a no, this is not a 0. In PyCharm, O looks like this. Awesome, so we know what marker each type of player will have. But let's say that we want to use the symbol somewhere in our class, and we have to use it multiple times, which is something that could occur if we want to extend the functionality of our program. How can we make our code easier to maintain? Let's say that we want to change these values, and we've been using them at several different lines in our code. What are we going to do? We are going to create a class constant or a class attribute that will serve as a constant that we can refer to in our class. We say player marker and computer marker, which is O. We're kind of like creating a central point where we can update these values. And then we will refer to these attributes in our code. And if we make any updates, they will be updated automatically anywhere we use them. So right here, instead of writing X, like we have right here, we are referring to the player marker attribute of the player class. So if I update this, for example, to C, or to a different character, this will be updated automatically and anywhere in our code where I use it. Now let's say computer marker, and this will work exactly the same. We're just thinking ahead and thinking about how our program might grow in complexity and how we can make it easier to maintain. Awesome, now we have our init method, which runs when we create a player instance. We're going to define some properties. For example, we will need to access the isHuman attribute, but we don't want it to be modified. So we're going to make it read only, and we're going to create a getter for this attribute using the add property decorator. We're going to do the same with marker, because these are attributes that exist, but we don't want them to be modified. We only want to access their values. Like this. The main functionality that we have to implement for a player is to make a move. So we're going to define a method that is going to return the move that the player selects. We're going to have like user interaction with the input function, depending on the type of player. Let's see. This method will be getMove. And what are we going to do in this method? We are going to check if the player is a human player. If the player is the human player, then we want to do something very specific, which is interacting with the user to get the input. We're going to use this method like the main central point that is going to decide what type of move we are going to get. If the player is the human player or if the player is the computer player, like this. Return self.getComputerMove, like this. We haven't defined these methods yet, so this is why we are getting these warnings on resolved attribute reference. But we will do that in just a second, so don't worry. Notice that we are returning right here the values returned by these method calls. This is very important. If we don't write this return statement, then this method getMove will not return a value. If we just write this method will return none automatically. Because we are not returning a value explicitly, we have to write return. These methods will return the move, and this statement will return that move from the method. So let's start defining our getHumanMove method. This is the method that will be called if the player is a human player. So we need some user interaction, and let's start working with the input function. We're going to use an infinite loop right here, but it's not really going to be infinite. We say while true, so this will run indefinitely until something very specific happens. We're going to ask for user input, and we're going to store it in the variable user input. We're going to take an integer. We're going to ask for the number of the cell that the user wants to choose as the move, from 1 to 9. So right here we write the input function, and we're going to convert the input to an integer. Please enter your move. We can also add like a visual cue, like saying from 1 to 9, or you can customize this message to your liking. It's totally okay to customize this to make this game your own. Great. So now we have user input, and once we have the user input, we need to create a move object. Remember that we defined the move class right here in our previous video. So we're going to create right now a move object from that user input. The move class has an init method that takes a value. So when we create a move object, we need to take the value from 1 to 9 to create the move. And that is what we are passing right here. The value from 1 to 9 to create that move object. But right here we see a warning, unresolved reference move. And we can solve that very easily with an import statement. This file, the player file, doesn't have access to the move class because it is in another file. We can import the particular class. Instead of import right here, I'm going to write from move import move. So we can use the name of the class directly, like we do right here, move. Great. You can see that the warning has disappeared. Awesome. We have our move. After we have the move, it's very, very important to check if the move is valid, because we don't want to work with an invalid move. For example, if the user enters the number 15 or 25 or -5, we don't want to work with that move. That will generate a lot of errors in our code. So, first of all, we have to check if it's valid. And for that, we call the isValid method of the move object. This is a very nice example of how we can work with objects of different types and use their methods and use the structure that we have been defining in our classes. When we call this method, we will get true or false, depending on whether the move is valid or not. Remember this method in the move class. This is the method that we are calling isValid. This will return true if the value is between 1 and 9 inclusive. Okay, so now we get this value, and if that is true, then we break out of the loop. We got the user input, we created our move, and now it's time to move on and return that value. So we use break. Break is just like a stop sign that you see on the streets that immediately stops the while loop. You can think of it like a stop sign that immediately stops the loop. And it continues with the normal flow of execution of the program after the loop. But if this is not the case, if the move is not valid, if, for example, the user entered 15 and that is not a valid number, we should print a message. Please enter an integer between 1 and 9. Okay? Notice that right here in this else clause, we are not writing a break statement. So we're just going to print the message and the loop will continue. It will start again asking for user input. That is what we want. We want to ask for user input until the user enters a valid value. We will not accept the value until it is valid. Awesome, so after we break out of the loop, we will jump to this line, return move. We will return that move object that we created from the user input. And that is the implementation of getHumanMove. Now we are handling the case where the player is a human player. We will get the move through user input. So now we have to implement what happens when the player is actually the computer player. When we have the computer player, things are a little bit different because now we cannot have any user input. We have to select a number from 1 to 9 randomly. And that is exactly what we will do right here. getComputerMove. Awesome. What are we going to get? We are going to get a random choice for the computer. We are going to do that by using the choice function from the random module. And that's right, that is a module, so we have to import it. Otherwise, we will get this error, unresolved reference random. So we go to the very top of our file, and right here we import the random module. Usually, it is recommended in Python to first import the built-in modules, like random or any other type of built-in and more general module first, and then import more specific modules or modules that you have created for the project. Okay, so now the error is gone because now we've imported random and the program has access to these functions. Now we can use the choice function, we can call it, and what are we going to pass as the argument? We're going to select a random value, but we have to specify a particular interval or range of values to make that choice. And what is the valid range of values? Well, from 1 to 10. Okay, this is the valid range of values. We can convert this sequence to a list as well. We can take this sequence, we can also write just a list from 1 to 9 manually because we only have 9 values, but I think that this is a little bit more compact. So we're creating a sequence from 1 to 9 and then we are converting it to a list and we are selecting a value randomly from that list from 1 to 9. After we have that random value, we have to create the move. We're going to do exactly the same as we did for the human move right here. We create the move. We pass a particular value for the move, which is in this case the random choice, and we assign it to the move variable. After that, we just need to print a message to let the user know what value was selected randomly for the computer. We print computer move from 1 to 9, and we need to print the value of the move. Remember that right here, move is not an integer. It is an object that we created from the move class. We got the random choice, which was an integer, and we passed it as an argument to the move class to create an object. And now, right here, we have an object that we can use in our code. And that object has a value attribute. Okay, so we can use that, and that will give us the value of the move. And finally, we have to return the move, because we are going to work with it in our code later on. Great! Now we have implemented all the main functionality of the player class. Right here, PyCharm is asking us to add another blank line between the import statements that we have right here and the class definition. Great, so let's go through this code one more time quickly to go over the details before we move on to the board class. In the next video, we will start implementing the board class. So let's review our player class. Right here, we define the class with two class attributes. Okay, that is why we are writing them in uppercase letters. We want to tell other developers that these values should, in practice, be like constants. They should not be changed. So we have X and O, and right here we have the init method with an isHuman parameter, which by default is true. So right here, we are creating an instance attribute isHuman, and based on whether the player is human or not, we are also assigning a value for a marker attribute. These attributes are non-public, so we are creating properties for them so we can access their values, but we don't want to modify them, so we don't create setters. Right here, we are defining a getMove method. This method returns the move for that particular player. In this method in particular, we are handling the two different cases for the two types of players. We are saying if the player is a human player, then we are going to get a human move, which is going to be the result of user input. But if the player is a computer player, then we are going to get the computer move, which is going to be a random selection from 1 to 9. In the getHumanMove method, we have an infinite loop right here, which is going to stop when the player enters a valid move. So right here, we are asking the user to enter a value between 1 and 9, which is the cell that he or she wants to select for the move. We are converting that to an integer, and we are creating a move from that value. If the move is valid, we break out of the loop, and we return the move object. But if the move is not valid, we say please enter an integer between 1 and 9, and then we start again until the user enters a valid input. And finally, right here we have the getComputerMove method, which is going to select a random value in a range from 1 to 9 inclusive. This 10 right here, remember that range doesn't include this value, so we are getting a sequence that goes from 1 up to 9 inclusive. So that random choice is going to be used to create a move object. And we take that object and we get the value to present it to the user. And then we return that move. You could add the space right here, or you could omit it, because this, adding a comma, will already add a space between the string and the next one. So these are both valid alternatives. Great, so we have our player class. Take a few minutes to go over this code, make sure that you understand it, and then move on to the next video. I will see you there. Now we have our move class and our player class. That's great. But now we have to test our player class to make sure that it works like we expected. We're going to do something very similar to what we did with the move class. We're going to call the methods and test them with different inputs. Okay, so first of all, we need to create a player instance. We will do this right here below, player, and by default, since we assigned the value true to the parameter isHuman, the player will be a human player. So we can start by testing the functionality of the human player. We can add a comment right here, human player. Awesome, so once we have a human player, what can we do with it? Well, we can test if the instance has these two instance attributes, isHuman and marker, which we defined right here as properties, so we can get the values of these attributes. Let's print player.isHuman, this should be true, and player.marker. We should check that the marker is an X, which is the marker that we selected for human players. If we run the code right here, we see this as the output. We see exactly what we expected. Player isHuman is true. The attribute is true because the player is a human player, and the marker is X, which is a marker that we wanted to assign to the player in the Tic-Tac-Toe game. So these two properties are working correctly. So now let's move on to testing the methods of the class. First, we find the method getMove. Okay, getMove should return a move object for the human player. And this will indirectly test the getHumanMove method, which should ask the user to enter a move and continue asking while the input is invalid, and if it is valid, it should return that move object with the value that the user entered. So let's do that. We say player and we call getMove. This method doesn't take any arguments, so we just call it with empty parentheses. If we save the file and we run the code, we see this. Please enter your move from 1 to 9. Remember the structure of the board? Each number marks a particular position on the board from 1 to 9, so let's say that we choose the value 2. And we don't see any errors, everything ran correctly. But to be more specific in the output and to check if the move that we get was actually the move that we expected with the value 2, we can assign the value returned by this method call to a variable, and then print the value of the object, of the move object, like this. Let's run the file again, and we see the prompt. Please enter your move 1 through 9. Let's enter 2. And now we see the value 2, because we're printing that value, the value attribute of the object that we just created. In this case, the value is a property. So that is great. We are creating a move object with this method, and we are returning it. And we are creating it by asking for user input. So the methods are working like we expected, at least the getHumanMove method and the getMove method. But there is also another case that we need to test for getMove for the human player. What happens if the player, the user, enters an invalid input? That is something that we should test as well to check if it works correctly. For example, let's say that I enter the value 0. This is not a valid value for the board, so let's click enter and see what happens. We see please enter an integer between 1 and 9. And then we see the prompt again, so we can enter a different value. Let's enter an invalid value again. And we see that the process continues. This is correct. Let's enter a bound of the interval, for example 1, and see how it works. And we see 1, which is correct. And that is awesome. If we enter invalid input, the program will handle it nicely and the process will not stop, but it will continue and it will tell the user what has to be done. Great. If we run the code again and we try the other bound of the interval 9, we see the value 9. So the code is working correctly, like we expected. Okay, so now what we have to do is to test the other branch of this conditional, the other part of this conditional, where we get the computer's move. But for that, we have to create a different type of player. We have to pass the value false right here to create a computer player. If we pass the value false for isHuman, we will have a different marker, the computer marker, which is an O. And we will assign it to the marker attribute. Great, so now we have our computer player, and we have to get a move. But to avoid any confusions, we can change the name of this variable to computer. And then we're going to call the getMove method. Okay, so we get the move, and then we're going to print the value. This value is a random value selected from the range of valid values. And we should also see the output of the computer move printed in the console. So this should not be necessary. Okay, so we can delete it, at least for the computer player. If we save the file and we run the code, we see this. Computer move from 1 to 9, it was 2. So that was the value that was randomly selected for the computer move. Now if we run the code again, we see a different value, 8. Then we see 5. So you can see that this is actually a value that we are selecting randomly. 1 is being included in the sequence because we got it right here randomly. And then 6, 5, and you can continue and you will get different random values. So this method is working correctly as well. We're getting values in that range, and we are also getting the move object right here. If we want to check if this is actually a move object, the type of the object, then we could try printing the object. And we can see the output. We can see that this is a move object. So this is an object of type move at this particular memory location. And this confirms that the method is returning a move object, like we expected with this return statement. Great, so now we tested all the methods in the player class. And we checked that they are working correctly. We also have the 2 instance attributes that we need. When you're ready, go to the next video where we will start implementing our board class. If you want, you can take a few minutes to go over this code again and make sure that you understand move and player, because we will need them when we start implementing board and the main game logic. So when you're ready, I'll see you there. Okay, so now we have our move class and our player class. So let's start writing our board class. To do that, we just create a new Python file right here. And we're going to name this board. Initially, it will be blank, and let me zoom in so you can see this better. So we're going to start defining our board class. For that, we need the class header first, of course. And we have our colon at the end of the header. That is very important. What do we need to have as our initial board? Well, we need to have an initially empty structure. When the game starts, the board is empty. So we need to reflect that in our representation of the board. How are we going to do this? Well, we are going to create an attribute called GameBoard. It's going to have nested lists. It's going to be a list that contains lists. Each one of these lists is going to represent a row on the board, a row. You will see what I mean in just a second. Just picture this as a board. And within each row, we're going to have 3 columns. So we're going to have 3 elements. And the elements are going to denote what type of value we have at that particular row and column. This is our first row, this is our second row, and this is our third row. But this is not really looking like a tic-tac-toe game board, right? How can we help ourselves visualize this even better? Well, we can just press enter right here. And you can see how this is starting to look like a tic-tac-toe board. We have our first row, our second row, and our third row. And right here we have the different columns of the game. But of course, we're not going to show this to the user. It's just like an internal representation that we will use. This will be our initial representation when we create a board instance. So that is why I'm writing this in the init method, because it will be created automatically when we create an instance. It will also be helpful to define a class attribute called empty cell. This is like a constant that we can use to add more context to our code, to make our code more readable, where we assign the value 0 as the value that we will use to denote an empty cell on the board. This denotes an empty cell. So we know that this is empty, and this is what we will use to check if a cell is empty or not. You could also write this right here instead of the 0. Okay, so in this video, we are also going to implement a method that is going to print the board. This is very, very important. We are going to print a board that shows the positions to the user first, so the user knows what value he or she has to enter from 1 to 9 and what position that value corresponds to. And we are also going to have a method that is going to print the current state of the board. If the cell is empty, it will be empty, but if the cell has an X or an O, that symbol will be printed as well. Okay, so let's start defining our print board method. This method will not take any arguments, so we just write self. The first thing that we will do when we print the board will be showing a board with the positions. So we could name this method, for example, print board with positions. You can customize the name of this method to what you think is more convenient. In this case, I am going to name it print board with positions. And trust me, this will be very helpful once we've implemented this. Right here we see positions, because this is a message that will help the user know what we are referring to with the board. And this character right here adds a new line, so we separate it from previous messages, and that will help with the presentation. We can start defining this method to remove this error or wording that we have right here. It is very, very quick a very quick implementation. It's actually just one line, so we can implement it right now. What are we going to print? Well, we are going to print a board like the one that I showed you on a previous video with the numbers and the spaces and the bars and exactly what the board will look like when we print it in the game. Like this. We write the first row, then we write a new line character, so this will be separated from this part of the string by a new line, then we print another new line character and the third row right here. Awesome, so we have our initial board class. Let's start testing what this looks like. So you have a clearer view of what we're trying to accomplish with this code. We're creating right here a board instance to test this, so I'm going to call print board. Okay, so let's run this file, and right here we see this. Positions. And we see the board with the corresponding positions, 1 through 9. So the user has a clear idea of what number he or she has to enter to put the marker at that particular position on the board. Awesome. Let's comment this out for a moment because we will continue testing our board, but we have to finish the implementation of print board. After we print the board with the positions, this is going to be like a fixed value, so that is why we are printing a string with fixed values. We don't have any variables right here. But what we do have to do is to print the current state of the board, like this. We are going to print the board row by row and column by column. Let's see how we can do this. For each row in the board representation, remember that right here we have 3 lists. And we have a main list right here. So we have nested lists. When we write this in a for loop, we're iterating over each element in the list, the main, the outer list. So we're going to have 3 iterations, 1 per row, 1 per element in the outer list, and the elements are the nested lists that we have right here. After we have that set up for the for loop, we can start printing the structure of the board. Every row starts with a vertical bar. So we should print that as the first character, and then since we want to continue printing on the same row, on the same line, we write this as the second parameter for print. We pass this value as the second parameter and an empty string. We want to continue on the same line, but we don't want to separate the next character. After we have that initial character, we have to start printing the columns. Each one of these values represents either an empty cell or a cell that has an X or an O. And those values are the ones that we have to print, column by column. So we say, for each column in the row, we are writing nested loops right here. We are taking each row, each one of these lists, and then for each list, we are taking each one of its elements, right here with the nested loop. So we say for each column in the row, if the column is empty, so if the value at the column is equal to 0, this right here represents the value 0 because we are writing this right here. If the value is 0 at that position, then what are we going to do? We just need to print an empty cell. And we can do this by writing 3 spaces, 1, 2, 3, followed by our vertical bar. And then we write and an empty string. Why are we writing this right here instead of 0, you may ask? I'm sure this is a question that you must have on your mind. I think that adding this right here adds a little bit of context or meaning to our code to make it more readable. If instead of this we write 0, it doesn't really help you understand that we are trying to check if the column is empty, right? So by adding this, we're saying if the column matches the value that we assigned for an empty cell, then do this. So that is why I'm defining this constant in the class. Great, so we are handling empty cells. And now we have to do something if the cell is not empty. So what are we going to do? Well, we are going to work with an F string. F strings are really awesome because they help us replace the values of variables and expressions in our strings in a very compact way and very readable way. We just need to write curly braces right here, and within the curly braces we write the name of the variable that we want to replace. And when we print the string, the value will be there. We also need to add a space before and a space after the character to make sure that the elements are aligned on the board. And right here after the space, we write the vertical bar. Remember that we're creating the structure for the board. And we also need to add end right here because we want to continue printing the remaining columns until we reach the end of the row. Great, so after we print the row, we want to start a new line. We can do this in Python by just writing print. That will add a new line character to the output and we will start a new line because we completed the row. And after we printed all the rows, we also want to print a new line. Trust me, I tested this and this will really help us present the output nicely to the user because we're creating like a division between the board and what comes next in the output. Awesome. Let's test how this works in the output. I'm sure that you must be really curious to see this in action and to run this in your device. So let's uncomment this code and let's print the board. Okay, so let's run the code right here and we see this. Positions 1, 2, 3, 4, 5, 6. We see all the positions and we also see right here below a board with empty cells, of course, because the board is initially empty. We only have spaces. But what happens if right here, just for testing purposes, we change these values to, for example, X, O, X, X, and O right here. For example, something like this. Not all the cells are empty now, so we should see these symbols right here being replaced. And we see exactly that. Let me make this a little bit bigger so you can see we see the positions. This is a fixed string that we are printing, and right here we are printing the current state of the board, which is the state that we defined right here initially. Game board. So we are replacing the values correctly and we have a correct alignment of the vertical bars for the board. Great, so this is the implementation of print board and we tested that our code works correctly. Right here we should bring this back to the original state with empty cells. This attribute, this value will be updated as we run the game. So when we print the updated state of the board, the values will be replaced, the X and the O's. Let me delete this test code and let's move on to the next video. Please feel free to take a few minutes to go over the code again and make sure that you understand how it works, because in the next video we will be implementing additional functionality for the board. So when you're ready, I will see you there. Welcome back. Now we will implement a method to submit a move to the board. If we go to the last method of the class, we can start defining our new method. We will name this method submitMove right here. This method will take two parameters, the player and the move. And move is a move object. To submit a move to the board, we will need to know the row and the column of the move. Because right here, we are working with nested lists. So we need to get the index of the row to determine which one of these lists we are going to modify. And we also need the index of the column to determine, once we've selected the list, which one of the elements in that list will be modified. These are the row and the column, so we need both of them. Right here, we are going to assign them to variables to improve the readability of the code. You will see why in just a moment. Row and column. You could also name this call if you want to abbreviate the word. Okay, get column. We get both of them, and then first we want to check if that particular position was already taken by another character, if it was not empty. So we can do that by getting the value that is currently at that row and at that column. You can see that I'm using right here 2 indices instead of 1. This is because we are working with nested lists. So the first index is selecting the list that we want to access. This is the row. And the second index is selecting the column. Because once we selected the list, let's say that this was the list selected, we need to get the index of the element. It could be 0, 1, or 2, depending on the position selected in the move. Okay? So we get the value. And we say, if the value is the value that we assigned or used to represent an empty cell, then that means that we can submit the move and it is valid. There are no conflicts or anything of the sort. So what can we do? We can do this right here. We take that particular position on the board, the row and the column, and we assign the player's marker to that position, to that particular row and column in the game board. We are replacing the value 0 that previously represented an empty cell. That is if the cell was empty, but if it wasn't empty and this condition was false, then what can we do? We can print a message to let the user know that this position is already taken. Please enter another one. In this case, we're going to make the player lose the turn if he or she enters a position that was already taken. The same will happen with the computer. If the computer selects a position that was already taken, the computer will lose the turn. Okay? Awesome. So we have the submit move method. Let's test this to see how it works. Let's see that it works correctly. We create a board instance right here. And then what do we want to do with the board? We are going to submit a move. For testing purposes, we will create a move object with the value 5. And we will also create a player object, a player instance right here. But we see errors because we don't have access to these classes in our module, in our file right here. We can solve that easily with an import statement. From move, import move, and from player, import player. You can also change the order. That is completely fine, okay? And now we see that the warnings are gone. So what are we going to do? We're going to submit a move. First, we need the player, and then we need the move. But to check if the move was successfully submitted, we are going to print the board before we submit the move, and we are going to print the board after we submit the move. So let's save the file and run the code and see how this works. Right here, we see the output of the first line, print board. We are printing the positions to remind the user what integer represents each position on the board. And right here, we are printing an empty board, which is what we expected initially. Then we submit the move. The move is position 5 is to place a marker at position 5. So this marker, the player's marker, should be at position 5. The player's marker is an X, so we should see an X at position 5. And that is exactly what we see right here. This is the output of this line, print board. We see the values from 1 to 9, and right here we see the updated board. The number 5 represents this position on the board. So right here we see an X. The board was successfully updated. And our method is working correctly like we expected. So this is awesome. Now we have our submit move method completed. Since we are not going to need necessarily these import statements, we can just delete them and delete the code that we use to test this method. Okay? So we have the implementation and we can continue working on our board class. So we'll see you in the next video. Take a moment to go over this code and make sure that you understand how the submit move method was implemented. Now let's implement the methods that we will need to check if the game is over, if one of the players won, or if there is a tie. Let's implement this. If we go to the bottom of our class, we can define this new method. Check is game over. Okay? We can also have a situation where there is a tie, but we will handle this in a different method. We are going to take the player as an argument, and we are going to take the last move that was submitted as the argument. Why? Because when a player submits a move to the board, we're going to check this automatically. We're going to check if the game is over because the last move submitted by a player made the player win the game. We will take the last move and we will check the row, the column, the diagonal, and the anti-diagonal. And we will return true if either one of those cases is true. In that case, we have a game over. The player won the game. And if that is not the case, we will return false. So, how are we going to do this? We're going to write a multi-line condition. And this condition will rely on the results of several checks or several method calls that we will make. We're going to define a method called checkRow. That method is going to take the player and the last move as the argument. That method will return true or false. But we want to check if this condition is true or if either one of the next conditions are true. Or if self.checkColumn, in this method we are going to check if the column is full with the player's marker. Or if self.checkDiagonal, we're going to check the diagonal. In this case, we're only going to take the player because we don't need the last move. The diagonal is only one sequence of values and we don't really need the move. We only need to check those 3 values that are in the diagonal. And we are also going to check the anti-diagonal. Okay, so we have these conditions. So everything is correct. We only need to define these methods and what they are going to do. Why are we using the OR operator? Well, because we want to return true if either one of these conditions or of these method calls return true. If either one of them returns true, then we return true immediately. But if they are all false, then we will return false. So that is why we are using OR. Because with OR, if either one of the values is true, the result is true. Awesome, so let's start implementing these smaller methods. checkRow. This method takes the player and the last move as an argument, because we need to know the row of the last move to check that row. How are we going to check this? First, we need to get the row index. I'm calling this row index to be more descriptive. So we take the last move and we get the row. And we also want to get the actual row from the board. First, we get the index for the row. And then, once we have the index, we know what list we are referring to. Either one of these. It could be list 0, list 1, or list 2. That would be row 0, row 1, and row 2. Either one of them. We will get that index, and then, using the index, we will get the actual list that corresponds to that row. With this, okay? We're getting the row with the values. Because we want to count how many times the player's marker appears on that row. If it appears 3 times, then the player won, because the row is full with his or her markers. What are we going to return? We're going to count how many times the player's marker appears on the row. We take the row with the values. This is a list. Initially, it would be 0, 0, 0, but it could be 0 or O, 0x, and this would be something like this. We will take that row and we will count how many times the player's marker appears on that row. So if the marker is, for example, x, if it is the human player, this would return, the count would return 1, because we only have 1 occurrence of the marker. And we want to compare this with the value 3. If the value is equal to 3, then we return true. Else, we return false. So we can write the condition right here directly next to return, and that will make our code much more concise. And there we go, we have our checkRow method. Awesome. The logic for the other methods is very similar. checkColumn. This method will take the player and the last move that was submitted. In this case, we can't use the count method because this is a method that we can use on lists. But for the columns, we are not working with actual lists. We are working with different lists right here. We have 3 lists, and for a column, we have elements on different lists. They are at the same index, but they are part of different lists. So we can't use the count method. We actually have to keep track of a counter ourselves. So we're going to create a variable. We're going to define the variable markers count. And then we also need to get the column index from the move. We take the last move and we get the column. Okay? And we assign it to the column index. After that, we need to do something 3 times. We need to get the value at row 1 at that particular index, at that particular column. Then we need to get the value at that index at row 2 and then at row 3, which are actually rows 0, 1, and 2 when we start counting from 0. Right here, we are going to have a for loop. For I in range 3, because we have 3 rows. We say, if we take the board, at index I will be 0, 1, and 2, so we are like going from row 0 to row 1 and row 2. And we take the element at that particular index. The index of the column is fixed. It is a fixed value because we're taking the values at that index of the different lists that we have, of the different rows. And if that element is equal to the marker, then we increment the count by 1. That is what we will do. And then we're going to return true if the markers count is equal to 3. Else we're going to return false. So we write the condition right here next to return. Great, so we have our check row and our check column methods. Now we just need to implement our check diagonal and check anti-diagonal methods. For check diagonal, we don't actually need the move because there is only one diagonal. The diagonal is made of these elements that we have right here. At row 1, column 1, row 2, column 2, and row 3, column 3. If we start counting from 0, that would be 0, 0, 1, 1, and 2, 2. So we see the pattern that the index for the row is equal to the index for the column in this case, and we can use that. And that is exactly what we will do. We will also keep track of a markers count, but we will use a for loop for I in range 3. We say, if self.gameBoard at index II, remember that this will return a sequence with the values 0, 1, and 2. So initially, I will be 0, so it will be the game board at row 0 and column 0. That is this element right here. Then it will be 1, 1, which is this element right here, and then 2, 2, which is this element right here. So we will be getting the elements of the diagonal one by one. And right here, we are comparing if that element is equal to the player's marker. Okay, so we update it by incrementing it by 1 if that is the case. And then we return true if the markers count is equal to 3 and false otherwise. Let me delete this comment. And finally, we are going to check the anti-diagonal. The anti-diagonal is this one that we have right here. Instead of going to the right, instead of going like this, we're going to the left, right here. This has a particular pattern that we have to think about and we have to analyze. We start by defining the markers count, and then we're going to do exactly the same. We need 3 iterations. But to get the index for the column, we need to use a specific pattern right here. We're using I because we want to go row by row, but to get the anti-diagonal, we need to use this right here, 2 minus I. Initially, I will be 0, so we will get the column 2. Then I will be 1, so we will get column 1, and then we will get column 0. We will go exactly like this. Column 2, column 1, column 0. And we are incrementing the value of the row, so we're going down. That is basically what we are doing right here. If that is the case, then we update the markers count. and we return true if the marker's count is equal to 3 and false otherwise. Awesome, so we have these 4 methods. Right here we also see a warning because we need to take the player. That is something very, very important. We need to add this to the list of parameters because we need to get the player's marker. Okay, so now we have these 4 methods implemented, and they will be very, very helpful to decide if the game is over or not, if the player won the game or not. We can also check if there has been a tie and reset the board. And these are methods that we will implement in a coming video. But in the next video, we will test this method, check is game over. We will check what happens if we win by filling a row, a column, the diagonal, or the anti-diagonal with the player's marker. So take a few moments to go over this code and then go to the next video. I will see you there and we will start testing this functionality. Great, so now that we have our methods right here defined to check if the game is over, if the human or the computer player won the round, and we also have check row, check column, check diagonal, and check anti-diagonal, we can start testing our code. So to do that, we're going to create a board instance. We should add 2 blank lines before this line, and we create a board instance. So after we have the board instance, we're going to test how the game is working so far by playing the game and checking if the game is over. We're going to fill a row, we're also going to fill a column, we're going to fill the diagonal and the anti-diagonal in different rounds. So for that, we're going to create a player instance. We just temporarily need to import the player class from the player module. And we will also need the move class from the move module. We import them like this. And right here, we're going to create those instances. Player, and we create the instance of player. We also want to get a move. And after that, we just want to test what happens when we submit a move. And then we check if the game is over. Okay, so we will submit 3 moves. That's all it takes. 3 moves is all it takes to complete a row, a column, the diagonal, or the anti-diagonal. So we will submit those 3 moves. First, we will print the board to show the initial state. Then we will submit 3 moves. So we need to call this method 3 times, submit move. And finally, after we submit the move, we are going to check if the game is over. We will call this method. And by calling the method, we will get a Boolean value, true if the game is over and false if the game is not over yet. You can see how we are slowly building up all the functionality of the game, and we're also testing how the individual methods work. Great, so we will submit 3 moves. For that, we will have to get 3 different moves right here. We're just doing this to test our code, remember. We haven't reached the phase where we implement the actual game. We are just creating these instances to check that this method works as we expected. Okay, so what move are we going to submit right here? Move 1, then move 2, and then move 3. And right here, for submit move, we also have to pass a second argument that we can check right here. First, we need to pass the player and then the move. So we're going to pass the human player that we defined right here above. Okay, player, and then the corresponding move. And right here, for check is game over, we also need to pass the player to check if the human player won the game. And we need to pass the last move that was submitted. And what was the last move that was submitted? Move 3. We are submitting the moves in this order. 1, 2, and then 3. You can see it right here in the 3 method calls. The last move was move 3. So we're going to check if the player won with the move number 3. Great, so let's save the file and run our code and see how this works. Right here we see this. Please enter your move 1 through 9. To visualize the board before we actually enter the moves, we should move this line right here before the method calls to get move. So we will do exactly that and we will rerun the code. And right here you can see the different positions that we can enter for our move. We see board, and then we see please enter your move. We will enter the numbers 1, 2, and 3. These are the positions for the first row. Right now we will be checking this method, check row. When we check if the game is over, if the row has been completed, the row of the last move will be this one right here when we enter the number 3. So if this row is full with the player's marker, then the player won the game. And this will be true. So the game will be over. That is what we are checking right now. So we will enter 1, 2, and 3. And we see the value true because the game is over. We filled the first row. And if we want to see this visually, we can just call print board again after we submit the 3 moves. We run the code again, we see the positions and the initial board. We enter the 3 moves, and then we see the updated state of the board. We have the first row completely filled, full of the player's marker, which is X, and right here we see true, because the game should be over after the 3rd move that we submitted right here. Great, so we are testing if check row works correctly. We know that when a row is filled, the game will stop. We can also test if this works with row 2 and row 3. So let's do that, just to double check that the code works like we expected. Now we're going to fill row number 2. So we're going to enter 4, 5, and 6. We can see that the row is full and we also see true. So the game should be over at that point. And for the 3rd row, we will enter 7, 8, and 9. 7, 8, and 9, and we see the row updated right here. So the method is working like we expected. Awesome, now let's start checking if the method check column works correctly. Now we will try to fill a column with our moves. So let's save the file and run our code again. We see the positions on the board, and now if we want to fill the column, we will have to enter 1, 4, and 7 for the first column. Right here we see the first column filled with the player's markers, and we also see the value true right here. So the game should be over. This method is returning true, which is awesome. This is exactly what we expected. Now let's also test what happens with this method if we don't fill a column after the 3rd move. We also need to check what happens if after those 3 moves we haven't filled a row or a column. So let's do that. Let's enter 1, 4. So we will have these 2 positions filled with a marker, and let's enter a different position that doesn't fill the first column. Let's enter the value 2. We see right here the value false. And that is correct, because the game should not be over if the column is not full, or if a row is not full. In this case, neither one of them is correct, and the diagonal is not full, and the anti-diagonal is not full. So, we see the value false. Great, so let's test this with the 2nd column. 2, 5, and 8. You can see that right here the column is full, and we see the value true. And if we test this with the 3rd column, we enter the values 3, 6, and 9. We see the 3rd column full with the markers, and we also see the value true. So this is working for all the rows and all the columns. And it's also working when we don't fill a row or a column after the 3rd move. So far, so good. Now we only have to check if this works with the diagonal and the anti-diagonal. So let's do that. The diagonal corresponds to positions 1, 5, and 9. So let's enter those values, 1, 5, and 9. And this is true. We can see this right here. So the game should be over after the 3rd move right here because we completed the diagonal. We can also check if this works if we enter the values in a different order. For example, 9, 5, and 1. We need it to work for every single combination because it doesn't necessarily have to be from top to bottom. We can fill the board any way we want to. We fill that by entering 9, 5, and 1, and we also see that the diagonal has been filled and we see the value true. So this is working as we expected. And finally, we need to check the anti-diagonal, which is this sequence of positions, 3, 5, and 7. Okay, so if we enter 3, 5, and 7, now we see the anti-diagonal filled with the player's markers, and we see that this is true, so the game should be over. Awesome! Our check is game over method is working like we expected, so we have the basic functionality of the board implemented. Awesome! In the next video, we will complete our board class. We will check if the game resulted in a tie, because right here when we check is game over, we are only checking if the player won, the human player or the computer player. But it could happen that the game ends up in a tie. So that is what we will implement in the next video. And we will also add a very short method to reset the board when we start a new round and we start with a blank board. Okay? So take a few moments to go through this code. If you want, you can continue testing it and making sure that you really understand how this works before you move on, and then I will see you in the next video to implement the tie functionality. Welcome back. Now we will complete our board class. I deleted the code that we used to test the methods, and right here we should also delete the import statements that we won't be using since we are not accessing the player or the move classes. Great, so let's go to the bottom of the class and let's start defining our check tie method, or check is tie, if the game is a tie, or if the round is a tie. You could also call this check tie to make it more concise. Great. So how are we going to check if there is a tie? If there is a tie, that means that the board is full. It is full with the human player's markers and with the computer's markers. But neither one of the rows, columns, the diagonal, or the anti-diagonal are full with the same marker. So how can we check if the board is full? We could count how many empty cells we have left. And if there are 0 empty cells left, that means that the board is full. So that is how we will implement this. We will count how many empty cells we have left. And if that number is 0, then the board is full. For each row in the game board, like this, for each row in the game board, we are going to update the counter of empty rows. We're going to take that row and we are going to call the count method to count how many times the number 0 appears on that row. Remember that rows are lists. If we go right here to our representation of a game board, you can see that each row is a list. So when we iterate over the lists for each row, we can call the count method on that list. And we can count how many times the empty cell appears, which in this case it would be value 0, but remember that we are using this to add more context to our code to make it easier to read. After we count how many empty cells we have, we just need to return true if that counter is equal to 0 and false otherwise. So we can do that very concisely with just one line. Right here we are comparing if the counter of empty cells is equal to 0. If it is, this will be true, and true will be returned. But if it's not, then this will be false. So there wasn't a tie. Awesome. Great, now we have a way to check if the game ended up in a tie. The last method that we will implement for the board class will be a method that will let us reset the board. This is the initial state of the board. Let me go right here to the top of the class, and right here we can see it. This is the initial state of the board where all the cells are empty. When the board is completely empty, when the game just starts, so that is the initial state that we want to restore. So we can just copy paste this right here if we want to, and go back right here to the body of a new method that we will define called reset board. You can also call this reset. And then we paste this right here. What we want to do when we call this method is to get a new game board that will be completely empty. So we can reset the current state of the board. We can remove all the markers that we added in the previous round. Great, so now we have these methods to check if there was a tie and to reset the board. In the next video, we'll be testing these two methods to make sure that the tie works as we expected when the board is full with markers, but there isn't a row, column, diagonal, or anti-diagonal full with the same markers. And we will also test how to reset a board. So I will see you in the next video. Welcome back! Now in this video we have all the functionality that we need for the board class. But we will be testing these two methods, the last two methods that we defined in the previous video. Okay, so we will need to import the player class and the move class. We say from player, import player, and from move, import move. You can see them in gray right here because we haven't used them yet, but we will do that in just a second. Right here below, we leave two blank lines and we start creating our instances. We define a board instance, we also define a player instance, and we get a move from the player like we did last time when we tested other methods. We can get the move from the player and we will have a move object. What are we going to test right here? We're going to check if we have a time. Okay, first, so we can first print the board to check that it is empty. Just to simulate that we are getting a tie, well, we're going to use a while loop because we are not sure of how many rounds we will need, how many turns we will need to get that tie. We will do that intentionally. So we can use a while loop, and we say that while it is not true that the game is a tie, right here, while board check is tie, if there isn't a tie, this value will be false. So by adding a not before that value, we continue the process. While it is not the case that there was a tie, we continue. Right here, I'm going to move this line to the while loop because we want to get repeated moves from the player. This will be the human move, and we also want to get a computer move. Okay? We're going to create another player, which is going to be the computer player, because we need to play against the computer to get a tie. We need to pass false right here, because as you might remember from our last videos, when we define the player class, right here we have a parameter that determines if the player is human or not. By default, this is true, so the player is human. But when we pass false right here, we're making the player a computer player. So we will get a move from the computer player. We will get these two moves, but we also need to submit them to the board. Okay, so we take the human player and we submit the human move. And right here, we also need to submit the move from the computer player. What move are we going to submit? The computer move. And we should also print the state of the board after we submit each move. Okay, so you can see how we are sort of like writing the main logic of the game already, making a simplified version of the logic of the game. We will implement that in a coming video. So we have this, and this while loop will stop when there is a tie. If there is a tie, this will be true. This negation, this not operator, will convert it to false, and the while loop will stop. Okay, and then we will print it's a tie. Notice that this line is not indented. It is at the same level of indentation as the while keyword, so it doesn't belong to the while loop. We will not repeat it. When the loop is completed, this line will run, and we will see this message. Okay? So let's save the file and run the code and see if we need to make any adjustments. Great, so we see the positions, we see the empty board, and please enter your move. Let's say that I choose 1. Right here, you can see my selection. My choice was to add the marker at position 1, and the computer selected the number 2 randomly, the position number 2. Right here, so we see an O. Now let's say that I choose position 3. Right here, you can see my marker at position 3, and the computer selected position number 5. So right here, we can see this. We want to have a tie. So right here, we should choose position number 8 to block the computer from choosing that position and completing that column. So right here, we can see that I selected this position number 8. And right here, before, the computer selected number 3, but that position was already taken, so we see this message, and the computer basically loses the turn. We can select another position, so let's say 6. Right here, the computer also selected number 2, the position was already taken, so we can say, for example, number 4. Awesome, so if we select the number 7, if we select position number 7, we will win. So let's just enter a position that is already taken, like for example, position number 1. We will continue doing this, entering position number 1 until the computer randomly selects position number 7. And you can see right here that the board is full, but neither one of the players has won the game. You can see the X, X, O. We don't have any rows or columns filled with the same marker. The diagonal is not filled with the same marker either, and the anti-diagonal is not filled with the same marker. So that stopped the loop immediately, as you can see, because the game stopped, the program stopped, and we see the message, it's a tie, the print statement that we have right here. Awesome. So this is working correctly. When we had a tie, this returned true. So this not converted it to false, and the while loop stopped. We jump to the slide, and we see that it is a tie. Awesome. The other method that we had to test before we actually start writing the logic of the game is reset board. We want to test if by calling this method we can reset the board to its initial state with empty cells. So we create the board, we create the player. Right here we won't need the computer player anymore. We will just need to get a move. We will get up the player's move, and then we will submit it to the board, like this. We also need to specify the player right here. We submit the move. We could submit 2 moves to get the board a little bit more filled with the player's markers. We submit move 1, and right here, if we copy paste this, we can submit move 2. If we print the board before we submit the moves, we will see the empty board. Then we will see the board updated with these 2 moves, and after that, we want to call the reset board method. Okay? Initially, we have an empty board. Then we submit these 2 moves, so we will see 2 markers on the board. We will print the board to see the updated state with the 2 markers, and then we will reset the board to its initial state. So it should be empty again when we print it right here. Should be empty. Initially empty, then it should have 2 markers, then we reset it, and now it should be empty. Awesome, so let's save the file and run the code and check that this works correctly. Please enter your move from 1 through 9. Let's say that I want to select positions 2 and 5. Expand this, you can see right here that we initially have an empty board. And then we have the updated board. I selected 2 and 5, which are the correct positions that you can see right here with my marker. And then after we call reset board, you can see that the board is empty again. So this is working, and we are getting an empty board again, without the markers that we had right here previously. We just see an empty board. So this is working, and we can use that method. We can call that method to start a new round with a new board. Awesome! Now we know that all the methods in the board class are working like we expected, so we can start implementing the main logic of the game in the next video. So go over this code one more time if you need to, and make sure that you understand how it works, because we will be using all of these classes to implement the main logic of the game. You should delete the code that we used to test the class and the import statements that we wrote. Those were used just temporarily to test the class. Awesome! I will see you in the next video. Awesome work! Congratulations for reaching this part of the project. We're in the final stage where we will implement the main functionality and logic of the game. So we will have a working game in just a few minutes. Right here you can see that I have the 3 classes that we defined: move, player, and board. We have to create a new file right here, so we will do that for our main game. New Python file, and we can call this, for example, game. You could also call it Tic-Tac-Toe. Great. So in this case, we're going to define the game as its own class. So we can have different methods that we can call. It's just a way to organize our code. But we could also implement it without defining a class. I'm just going to define the class right here, class Tic-Tac-Toe Game. Okay? This class is going to have two methods. One is going to be the start method and another one will be start new round. The start method is the method where we are going to write all the logic of the game, and the other method, start new round, will help us start a new round of the game. In this class, we're not going to define or customize a constructor. We're not going to have an init method. And this is a really nice example to illustrate that you don't actually need to implement an init method in all of your classes. If you don't write the init method, if you don't implement it, then you will just inherit all the attributes and methods that all objects in Python really have. So you don't really need to customize it if it's not necessary. Okay? We will start by defining our start method. When the game starts, the first thing that we want to do is to welcome the user, right? For that, we are going to print a message. I'm writing 3 print statements right here, and we will add like a little nice presentation with asterisks. I really liked how this looked when I worked on the game, so like this. Welcome to Tic-Tac-Toe. You can customize this message or this presentation any way you like. So you can make the game your own and customize it to your liking. The first thing that we have to do is to create the instances that we will be working with, just like we did when we were testing the methods of our classes. We have board, we have player, and we have computer. Remember that to create a computer player, we pass the value false to create the instance. Now you can see right here that we have all sorts of errors, and that is because we need to import the classes that we will be working with. So we say from board, import board, and from player, import player. These are the 2 import statements that we need right now, so those are the ones that we are going to write right here at the top of our file. And we should have right here 2 blank lines before the class definition after the import statements. Great, so we have our 3 instances, our board, our player, and our computer. First, we need to show the board to the user. We need to let the user know what positions he or she can enter, and we also need to show the user that the board is initially empty. After we have that, we will have something very, very interesting. We have 2 while true loops right here. One loop nested inside another one. You will see why in just a moment. But basically, this while true loop, the outer loop, is going to let us ask the user if he or she would like to play another round or to continue playing. And this nested while loop is going to have the main logic of the game. We can write this as, for example, main game or game logic. Basically, right here, we're going to get the move, we're going to check if there was a tie or check if the game was over because someone won, and print the corresponding messages. And that is basically the logic of each one of those loops. And you will see why we have to nest them in just a moment. Okay, so just to be more concise, I'm going to remove these comments, and we will start writing the nested while loop. First of all, we need to get the player's move, so we will do that like we have been doing so far when we tested the code. We call the getMove method of the human player. Remember that right here with player, we are referring to the human player. And when we write computer, we are referring to the computer player. Okay, so after we get that move, we want to submit the move. We need to specify the player and the player move. We submit the move, and after that, we want to print the state of the board, because the player will definitely want to see that the marker has been added to the board. After we do that, we have to check if there has been a tie, if the game is over, or if the computer has to make a move. So we will do that. If there was a tie, what are we going to do? If there was a tie, this will be true. Check is tie will return the value true. Okay, so right here we're going to print a message. It's a tie. Try again. We can also add like these small like emojis and see how they work, how they are printed or displayed in PyCharm. And then we say, else if there wasn't a tie, then we have to check if the player won. Then we say check is game over, but we want to check if the game was over because the player won with the last move that he or she submitted. And what was the last move? Well, the player move that we have right here, the most recent move that was submitted to the board. If that is true, then the player won. And we say, awesome, you won the game. And right here we can copy paste like a confetti emoji. Else, if neither one of these conditions are true, so there wasn't a tie, and the game is not over, the player has not won the game, then we have to get the computer's move and continue playing. How can we get the computer's move? Well, we call the getMove method on the computer. We are getting a move from the computer player and we are assigning it to a variable. After that, the logic is very similar to what we did right here for the human player. It's basically the same, we're just working with the computer player. We're going to submit a move and we're going to submit the computer move. Then we are going to print the board to see that the state of the board has been updated. After we print the board, we have to check if the computer won the game. Board.check is game over, but now we want to check if the game was over because the computer won with the last move that was submitted, the computer move, right here. If that is true, then we have to print a message. For example, oops. We can have like a little face right here and we say the computer won. Try again. And right here, we have something that we have to add after these print statements. That is a break statement. Let me zoom out right here so we can see this block of code more easily. We have a loop, a while loop, nested within another while loop. This loop, both of these loops, will run indefinitely until one of these break statements is found. When this break statement is found, the inner loop stops immediately, and it jumps to the next line of the outer loop. For example, if we have right here a print statement that says hello right here, let me remove this blank line so we can zoom in a little bit better. If we have right here a print statement that is not part of the inner loop, right here we have the inner loop, the nested loop, and we have another line that is indented at the same level, so it belongs to the outer loop. This is the body of the outer loop, and this is the body of the inner loop. This line belongs to the outer loop. So when the break statement is found, either one of these, because there was a tie, or because the player won, or because the computer won, then this loop will stop the inner loop, and the program will jump immediately to this line right here. It will continue the outer loop. We will use the outer loop to ask the user if he or she would like to continue the game or not, to play again with a new board. So we will do exactly that. We say play again will be a variable that will determine if we have another round. We ask the user, would you like to play again? Enter X for yes and O for no. We could say and or O for no. And we're going to get the input as an uppercase letter. Because right here we are asking for an uppercase X or an uppercase O, but the user could enter these letters as lowercase characters, so we are converting that automatically to uppercase, so we can use it in a conditional. We say, if play again is equal to O, this is an O in PyCharm. If we have a 0, then we have a small dot at the center, so this would be an O. If the user entered O, that means that he or she doesn't want to continue playing. So we say, bye. Come back soon. And we can add like a small waving hand. And then we will break out of the outer loop right here. We have the outer loop that is running continuously until it finds a break statement. Remember that these break statements that we have right here belong to the nested loop. These break statements will only stop this process that we have right here for the nested loop. Once that loop stops, we will go right here below, because this sequence of statements belongs to the outer loop. We go here, we ask the user if he or she would like to play again, and then if the user doesn't want to play again, we just break out of the outer loop and the process will stop. The game will stop. But if that is not the case, if the user wants to play again, then he or she will enter the letter X. And we will call a method that we still need to define that will be called start new round. And it will take the board, okay? As an argument. We will have to define this method below. Else, if the user entered a character that is neither O nor X, then that means that the character is not valid, but we can continue the game by saying something like this. Your input was not valid, but I will assume that you want to play again. And right here we have a small light bulb. After we do that, we start a new round again. Awesome! We have our implementation of the start method right here. We print a message. We create the instances that we will need, board, player, and computer. Initially, that will be an empty board, and then we start the logic of the game. We will continue the game while the user chooses to continue playing. And while the user chooses to continue playing, we will continue this logic. We will repeat this logic. We get the player's move from user input, we submit it to the board, then we print the board. We check if it is a tie. If it is a tie, we stop the process and we ask the user if he or she would like to play again. But if it isn't a tie, if this is false, then we check if the player won the game, and the game is over. We say, awesome, you won the game. Then we break out of the loop, and then we go here and we ask if the user would like to play again. But if that is not the case, if the player didn't win, then we have to get the computer's move. We get the computer's move, we submit it to the board, we print the updated board. And we check if the computer won. If the computer won the game, we print a message and we break out of this nested loop. So we ask the user, we jump right here and we ask the user if he or she would like to play again. And the user's answer will determine if the game continues. That is why we are writing nested loops right here. This outer loop determines if the whole game continues running, and this inner loop determines if the current round continues running. Okay? I think this is the best way to explain this or to describe the role or the purpose of these loops. This loop is in charge of the game logic, and this inner loop is in charge of the round, the current round that we are playing. When this loop stops, we stop the current round, and we ask the user if he or she would like to start another round. But if this loop stops, then we stop the whole game, and the process stops. Right here in the conditional, we're analyzing the user input. If the user entered O, then that means that he or she would like to stop the game, and we say bye, come back soon, we break out of the outer loop. But if the user wants to continue the round, then we will call this method start new round, which will do like an initial setup for a new round. And if that is not the case, then the character was not valid, we print a message and we start a new round. Awesome, let's start defining our second method. This method will be called start new round. It will take the board as an argument. So we define this parameter right here. To start a new round, we want to present a nice message to the user. To be more friendly, not just present the empty board without any messages or confirmations. What do we want to do with the board when we start a new round? Well, we reset the board. That is the first thing that we have to do because we want to start with a blank board. We don't want to keep the markers that we had in the previous round. And then we want to print the board after resetting it. Okay, we want to print it before we actually make the move right here. Because remember that when we print the board right here initially, that method call is not part of the loop. We print it right here, but that is not part of the loop, of the outer loop. Okay? Another thing that we could do to avoid writing this line right here could be to add this line right here before the nested loop. So when we start a new round, before we actually start the round, we print the board. Okay? We would delete this line and write it right here so we don't have to write it in the method. But let's just keep it in the method because that will help us determine what we have to do when we start a new round. Awesome, so we have the basic functionality implemented and we can start playing our game. For that, we have to create a Tic-Tac-Toe Game instance right here below. Notice that we are not indenting this, so this is part of the main program. This is not part of the class. We already have our class defined right here and we have the import statements that we need. So we create the game instance, and to start the game we have to call the start method. The method with the main logic of the game. So let's save the file and run the code and see how this works. We right click right here and we say run game. And we have our tic-tac-toe. So let's play. Welcome to tic-tac-toe. Positions 1 through 9. We have an empty board initially. Please enter your move. Let's say that I want to select the number 5. Right here you can see the updated board and the X, the player's marker, was added to position 5. The computer's move was 1, so right here we see the O at that position. Now let's say that I want to choose position 2. Right here you can see that I selected position 2 and we have the marker right here. We have the updated board and then the computer chose position number 9, which is this one right here. And finally, if we select the number 8, the position number 8, we fill this column with our markers and we see this message. Awesome, you won the game. We're also asked if we would like to play again. Would you like to play again? Enter X for yes or O for no. One small detail that we could fix right here is that we currently don't have a space to enter the input. So if I write, for example, the X, it will be right after the message. It's always best to add a space after this message. So if we go to the line where we ask for user input, we should add a colon and then a space. So the prompt will be right here. So that is a change that we will make, but we will continue playing just to test this and then we will run the game again to see that it was updated. Now we see that we start a new round. We see the positions and we have an empty board. So the reset board method is working correctly. Please enter your move, let's say 6, 3, and 9. Awesome, you won the game. Would you like to play again? Enter X for yes or O for no. We can enter O and we see bye, come back soon. So you can see how the nested while loops are really making the logic of the game come to life. We have the outer loop that is controlling the main game, the main logic of the game, and we have the inner loop that is controlling the main logic of the round. And it continues running while the round is alive, while the round hasn't been completed. And the outer while loop determines if the whole game continues running after we print in the board initially. Awesome, so let's run the game one more time to check that this was solved, that we have a space after that message. Let's say 1, 2, and 3. Awesome, you won the game. Would you like to play again? And right here we see the colon and the space that we added. So right here we see the prompt and we can enter our answer. We can also enter the answer in lowercase because right here on this line we are converting the input to an uppercase letter. So it is equivalent if we enter X. We start a new round. So the program detected that this X was equivalent to the uppercase X. Okay, because we converted the input to uppercase. Let's try this again, and now let's try entering an invalid input when we're asked if we want to play again or not. Let's just enter 1, 2, and 3. Would you like to play again? Let's enter the letter A, for example. We see your input was not valid, but I will assume that you want to play again. And we start a new round with an empty board. Awesome! Now you have your working tic-tac-toe game that we built following the principles of object-oriented programming. You use classes, methods, instances, and basically you combine everything that you've learned in the course so far. Well, great work! You completed your tic-tac-toe game. I will see you in the next section of the course.